Have you ever wondered how your food stay fresh inside the refrigerator, or how an air condition makes the whole room feel cool? Both of them give us comfort, but do you know how they actually work? Today we will discover the science behind this amazing machine. The science behind this refrigeration is based on simple principle. Heat always flows from a hotter area to a colder one. By using this principle, refrigeration system absorb unwanted heat and release it somewhere else, usually into the air outside. Did you know that most modern refrigeration is based on work on a compression cycle like this, and this, which has four main stages: compression, condensation, expansion, and evaporation. Refrigeration is the process of removing heat from a space, substance, or system to lower and maintain its temperature below the surrounding environment. From food preservation to industrial application, refrigeration plays a vital role in our daily lives. So we start our journey at the suction accumulator. This part makes sure no liquid refrigerant sneak its way to the compressor. Why? Because compressor are designed to handle vapor, not liquid. So the accumulator acts like a bodyguard. Only vapor gets through. Okay, from here, the vapor continue its path into the suction line filter dryer and enter the suction line filter dryer. Think of this as the air purifier of the system. It cleans out the moisture, dirt, or acid in the refrigerant, so the compressor can stay healthy and efficient. And after that is on, before reaching the heart of the system or the compressor, the refrigerant make a quick stop at the shut-off valve. This is like a gate. It allows the technician to close or open the line whenever maintenance or isolation is needed. And after that, we are in the compressor. And now the refrigerant arrives at the powerhouse of the system or the compressor. The compressor or the heart that keeps the full cycle alive. It takes in a low pressure vapor and compresses it into the high pressure or high temperature gas. From here, the refrigerant has the energy it needs to move around the entire system. As we can see, we have here the oil level gauge glass inside the compressor. Technician can check the oil using the oil level gauge glass, but since we don't want oil traveling through the system, the refrigerant passes through the oil separator air, which removes the oil and returns it back into the compressor. That's why lubrication stays where it's needed most. Okay, the next one is from here, the refrigerant can travel two different directions from them. And the first path, it may passes the hot into the hot gas bypass valve. These valves redirect hot refrigerant vapor back towards the evaporator. When the cooling load is low, it prevents freezing and help regulates performance. From the second path, here, the main route is the hot gas flow directly into the condenser. Here, the condenser. And now into the cooling stage. The condenser is like a giant radiator. Here, the hot high pressure vapor rejects its heat into the surroundings air. As it cools, the refrigerant condenses into the high pressure liquid. Going down into the receiver, it From the condenser, the liquid refrigerant flows forward into the receiver. Here. Into the receiver, this is basically a storage tank that ensures a steady supply of a liquid refrigerant for the system. And after that, going up into the filter dryer, before moving on the refrigerant gate, refrigerant gets another cleaning check here in the filter dryer. At the filter dryer, in the liquid line, this is one removes any leftover contaminants and moisture, making sure that the refrigerant is perfectly conditioned before entering in the expansion stage. As it moves into the liquid solenoid bulb here, now to the control the flow, the liquid line solenoid bulb acts like an automatic switch. It opens when cooling is needed and closes when it is not, preventing unwanted migration of a refrigerant. The next stop is the night glass moisture indicator. The sight glass, a little window for technician to check if the refrigerant quality. If the clear refrigerant, gold or bubbles might mean low charge, color change, warning sign of moisture. To check in the sight glass moisture indicator. And the next stop now comes from the most important stages is in the expansion bulbs or expansion bulb. The expansion bulb drops the pressure of the liquid refrigerant, turning it into a cold mix of liquid and vapor. Connected to it, it is the filler bulb, as we can see into the air or the evaporator side, which senses suction line and temperature adjust the bulb opening, ensuring just the right amount of refrigerant enters the evaporator. With pressure lowered and temperature drop, the refrigerant enter the final cooling stage. We have the evaporator. Here, the refrigerant absorbs heat from the air or product being cold. As it evaporates into vapor, it pulls heat away, leaving behind cold air or chilled surfaces. This is the stage where the actual cooling magic happens. Before heading back, the refrigerant passes through the evaporator pressure regulator. This device controls the pressure inside the evaporator, keeping the right balance to prevent freezing and to maintain steady cooling performance. And after that, back to the suction accumulator. And finally, the refrigerant returns. And that's it. And to the suction accumulator where the cycle begins again. This ensures only vapor re-enters the compressors and the refrigeration cycle continues and keeping everything cool. And that's the complete the refrigeration cycle from compression, condensation, expansion, and to the evaporation. Each part plays a vital role in keeping system efficient, safe, and cool. So the next time you grab a cold drink from the fridge or enjoy cool air from an air condition, remember this is not a magic, it is a engineering, and now you know the science behind the cool. Thank you.